All right, let's do this. Hello. Happy Sunday. My allergies are killing me today, so please bear with me if I have to keep getting up to go blow my nose or sneeze. Gonna be working on the procedural pathing that I was kind of showing last week, or back on Tuesday rather. That's really all I got planned today. Like if you look at the checklist here, this thing, basic enemy model has been fully put in, and he is all good to go. We'll probably revisit him a little bit later to add some more details to like his texturing, and maybe add some like cloth physics to his little I don't know what to call it. Saying skirt is wrong, but that's the only thing I can think of. Anyway, yeah, we've made a lot of progress with the pathing, and we're gonna keep going with that. Hopefully I can get that finished up this week so we can move on and get closer to the point of the playtest being able to actually run raids, right? That won't be for a little bit, but yeah. For those of you who aren't familiar or are just tuning in for the first time, I'm making a game called Jotun's Greed. It is going to be coming to Steam, and there's a free playtest available now. We are constantly updating that. If you want to go check it out, you can check the panels down below. You can type in the JG command in chat. You can find links to that there. You can join our Discord, the Fried Squid Games Discord, not my personal one. I mean, you can find it there too, but please, if you're interested, join the Fried Squid Games Discord, because we post update notifications whenever we update the playtest there. The playtest itself is also available on itch.io, but main platform is Steam. So yeah, that's my spiel. let's get into some game dev. All right, let me pull up my checklist here. Yeah, and I'm gonna be doing a lot of stuff with the details panel, which is like right behind me and right up here. So if it gets annoying that the checklist is here or that my face is here, let me know. I can move stuff around. But yeah. So, probably looks a bit different than the last time any of you saw it. Last time we were dealing with a square, like square borders. We've changed that to circular, because it just feels a bit more, I don't know, not natural, but like less obvious where like the edges of a circle are versus the edges of a square. Like you can obviously very easily find the corners and whatnot. We're just trying to make sure that we're not implementing anything that makes it easy for the players to navigate around, because we want them to feel kind of lost. Not lost, but like, you know, not a clear path forward. That's the idea anyway. So here, let me move this guy out of here because that's just a PCG volume I was playing around with. I'm also going to turn off the fog for now so it's easier to see. Here's our landscape, and if you were here before, you know that this landscape changes, right? So if I go to my map adder thing here, and I just move it, it should, looks like it generated the same one that time. It generates different landscapes based on height maps, right? So if we'll use this one. Yeah, this one looks like a good use case. So first thing that happens when this level loads is that it generates a new landscape. Then from there, we have to generate a path for PCG stuff to kind of spawn along. And that path will also help guide the player from start to finish, but you don't have to follow that path. It's more for PCG stuff to make it look like a real village. So that's what we're working on now, path generation. So let me show you how that works. So right now it's based on this navmesh volume, the navmesh bounds volume rather. And what it does is this blueprint here, which is a sphere, or it's actually a capsule, but it's scaled so it looks almost like a sphere. It sets itself to the bounds of the navmesh, and I tried making a cylinder navmesh bounds, and you can do that for like the brush, but it still generates a square volume. So we're just leaving it as a square just to keep things simple. But if you look, probably going to be hard to see, but the edges of this capsule's hemisphere, I guess, it's not like, you know what I mean, the max circumference here, the edges of that all touch the edges of the nav mesh, so it's set to the bounds of that. And so once we have those bounds set, which I can just make sure it's updated by hitting this one, I've exposed a lot of functions right here above my head, so that's what I'm clicking on here. So just want to make sure that's within that nav mesh, because we use that to do some pathfinding using Unreal's pathfinding system. So once we have our box extent, then we need to set our endpoints, which is a start and end, right? If we generate those, it puts them at opposite ends of the sphere. And let me bump this up a tiny bit, just so it's easier to get around. So this is the red square, so this is the end. This is where the player will end up at. And the white square is where the player will start. So, it's a good use case because we have this ridge here. We obviously don't want the path to go over this ridge. We want it to go around it. That's why we need to use pathfinding. So once we have our endpoints, then we can hit find path. And Unreal's system generates a path for us using, and it maps it to the spline here. And that's all good, but this spline, as you can see, has some weird tangents. The points aren't evenly distributed. It's just hard to work with in the way it is now, right? So if I take this spline and then I readjust the points. I can make them, you know, evenly distributed so the tangents aren't weird. I can, you know, give it more points so we can have more wiggle room, you know, because we want to modify it after this too. So let me hit add points to spline, and that's based on the number of points here, which you can see is set to 15 currently. Still playing around with that, but if I add points to spline, now we have a spline that's a lot easier to work with. And you can see sometimes the tangents are still a little weird, but if we hit it one more time, add points, it straightens that out a little bit better. So gonna have to play around with that a little bit because in some cases we don't need to adjust it more than once, but I guess it wouldn't hurt to. So maybe we'll just have it set to, you know, evenly distribute 2 or 3 times, just so we get something like this. So we have a good amount of points and they're all, you know, spaced out evenly. Because now that we have this path, we want to add some deviation to it, meaning we want to make the path kind of windy instead of almost straight as it is now. So that's what I'm still working on, because like I have something to add deviation, but the problem is right now it just adds a random deviation. And in a case like this, where there's this ridge, we don't want the deviation to then push the points back over this ridge, right? We want them to stay away from this. And that's what I need to do today. But you can see if I add deviation here, it now makes the path more windy, right? And of course it's not perfect. We get things like this. We don't really want that. But for most of it, like obviously out here it's going out of bounds, so we want to clamp that in. And then I think here it's putting the path back over that ridge. But anyway, just going off of this, once this path is then created, then we can say generate RBTs. And what that does is it slaps a texture onto our landscape, which is then our path, right? And so that's cool, but as you can see here, it's kind of putting the path along this ridge, and we don't want that. And it's also part out here. Yeah, this part is kind of out of the bounds. So we don't want that. But yeah, that's what we're working with here. So let me open up this path creator here. And let's see, so these are our functions. This is the add deviation event. I guess I should make this a function, shouldn't I? Let me pull this out and then say collapse to function. We'll call this add deviation. Oh, we can just say deviate. Sure. I can put this here. And then we can get rid of this stuff. We already know what that's about. Now if we open up our deviate function, here it is. Okay, first thing is I should probably clean this up. Before I do this, actually, I'm going to go to my project settings because there's something I need to check. I need to check that navigation is generated dynamically, not static, because the landscape is going to be changing. So we can't have a static navigation generation. Where did you go? Where are you? There you are, around my other window. Okay, so if we go to, what is it? Navigation system, I think? Yeah, gathering mode, no. Then our navigation mesh. Runtime generation is dynamic. Okay, so that's good. Eventually we'll probably come back to play around with what are they called? Something here for like I can't think of the name of it now. Invokers, navigation invokers. It's for like only enabling navigation data like around whatever the invokers are. In most cases, it's just the player, but it's just an efficiency thing. Makes it a little bit easier to I don't know, save resources, I guess. But yeah, we'll come back to that. Okay, so that's in place. That's good. So then, all right, we need to look at our deviation thing here. Let's try and clean this up as best we can. Let me just duplicate this guy so we can get this line out of here. Let's again duplicate him here. And then there for the endpoints. So we don't want to deviate the endpoints. We want the endpoints to stay where they are. What if we do something like this? And then something like this. And then something like that. This one's messy. Probably about as good as it's gonna get. And I realize I'm calling this deviation multiplier. This should not be a multiplier because it's not a multiplier. Let's change this to what do we call this? We'll just hang on to that for now because this logic might be changing. So, all right, so let's look at this here. First thing is we clear our path points array of vectors. This is what we use to adjust the points on the spline. We save it to this array of points and then just apply it right here. I've tried using the add point node and that just causes a performance hit. Trying to add points on a loop. So that's how we do it. We loop through, create this array of points, and then set the spline points based on that. So what we're doing is we're saying the number of spline points on the spline, which at this point it should have been distributed. So it's like the even 15 that we were looking at earlier. Says if this is the first or the last point in the spline, then we just want to add it to this because we don't want to affect the endpoints. If it's not the first or the last point, then we're randomizing it here. So the issue is with this because we want to, we were doing something earlier with a point index. We probably don't need that anymore. So we can probably take that out. All right, so what this does here is we say, take the point, which is just the location of that point. We break that into X and Y because Z we don't really care about. We're trying to keep it in 2D space just to make things easier. And then what we do is we take our max deviation here which is what we're playing around with. We take a random float in range of 0 to max deviation. And then on a random bool, we scale it times -1 or not. That's so that it goes either, left or right of the current point. And right now we're doing this on the X. And that just, because the point is going, the path is going, south to north, right, on the Y. So we're only affecting the X for this right now. Probably want to add something for the Y too, but for now let's just focus on the X direction. What we do is we add that, and then we clamp that point to our bounds, which doesn't seem to be working because, as you saw, there were points that were outside of the bounds. So if we take our capsule, we take our world location and our scaled capsule size, maybe we should just say get capsule radius. Plug that into here. So it takes the distance between our point and the center of the capsule. So it's saying if the distance between them is greater than the capsule radius, then we clamp it. Otherwise, just return the regular point, right? So our clamping value here, we take the world location of the capsule, which is like the center of it. We find the look at rotation, so looking from the center of our capsule to that point. We get our forward vector. That's the direction that we want to move out from the center to get to our point. Multiply that by our capsule radius, which should put it on the edge, and we add that in there. So that seems right to me. But, well, let me keep walking through my logic here. After we clamp that point, then we look at the landscape height. And what that does is it generates a line trace from that point straight down for a very long range. It's looking for the landscape below it. So it gets it's called get landscape height. I should probably say get landscape data because it returns this hit. And then we take the location and say get random location navigable radius. Oh, okay. So this is our issue probably, because once it gets that hit, it checks for a random location around that point. So that's what's pushing it back out. Yeah. So we need to only do this if the point is not navigable, right? What? Where? Oh. Okay, we don't need you. Okay. So yeah, that's our problem. Clamping is fine. It's just here. The reason I was trying to do this was so that it could, look to see, like, are we on a ridge or not? So maybe if because there's no way I can just say is point, can I navigate this point? I don't think. Let's see. Navigation. No, I don't want to do that. What does navigation raycast do? Need to look into that node. But yeah, we basically only want to do this if the point below us is not in the navigation. Right? What did we say? Anything we can do with navigation from a hit? No. Nope. No. 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 Let's see. Box. Valid AI location. I don't think that's what we want. Debug, shape, spatial math, rendering. Well, maybe we don't need to do that. Like, we don't need to check if there's navigation. We can check the normal, because the navigation data will only show up if there's a certain slope, right? Or lack thereof, I guess. So, we say normal. We say to string, and then I say print string. Actually, no. Let's make this a little bit easier on ourselves, and just go to the player and do it, because it'll make our lives much easier. Out of tick, we're going to do a line trace by channel. Start, we're going to get the count component. We're going to say get world location. And then we're going to do plus. And we're going to say plus negative 200 on the Z, meaning straight down. Tracing for visibility. And then on our out hit, we're going to break this hit result and get the normal. I'm going to say to string. Then we're going to say print. Print string for duration 0.1. That way we're not getting spammed with a lot of data. But you can see it's right here. Our normal is how is it increasing as we go up? So the Z value. Let's see, once we get to flat ground, the Z value is almost at 1. Right? It's getting very close to 1 at least. And our X and Y are getting very close to 0. But as we go up the slope, right, our Z goes down, and our X and Y go up. So how do we determine our slope here? Right, because we want to get the normal, because that's like the same, like the angle of the surface that we're touching. So moving Hmm. So let's look at our navigation settings again to see what our like max angle is. Right, agent max slope is 25 degrees. So meaning anything with a z value of 0.75 or greater for the normal is not navigable. Right? I think that's what that's saying. Let's try it. So we're gonna leave that there for now. Alright, so then we're gonna get the normal. We're going to break this vector. I'd say get the z value. If the z value is less than or equal to, we're gonna say 0.8 because I don't want it to be right along a ridge either. So we're gonna give it a little bit of a buffer. So if that's true, then we want to do this. Right? I feel like clamping should be the last thing we do. Because, yeah, like, this should not go here. This should go at the end. This should go here. And then we take this Z here. You go here. Right. And then we nope, don't do that. Don't want you. Put this. Okay, X and Y. That's gonna be a problem, I think, but we're gonna go with it for now. Split. We're gonna say get landscape height. Y, and then we're gonna do this again. All right. So then in this case, right? So if it's greater than, or no, we want it to be less than. All right. We have that backwards. We say if this is less than or equal to 0.8, we might bump that up a little bit later, but then do this. Otherwise, return what? This, right? No. Yeah, that's right. Okay. But we actually want to do the clamp here too, so guess that won't work. Do this. Do this. Yes. So we zoom out here. Let's do all this again. So set our box extent, that shouldn't change. Add our, generate our endpoints. Find our path. Add points to this line, we'll do that twice. And then add deviation. Ooh. Why did you do that? What? That's not what we want. Nope, get out of here. Not you. So you can go away. Did I do this wrong? Because when the normal on the Z is almost equal to 1, that's when you're flat, right? So if Z is less than 0.75, that's when you have a slope of 25 or greater. Right? So if this normal, the normal and the Z, that's why. Silly me. I was applying the normal. I should have been applying the location. Okay, let's try this again. Fair path. Generate endpoints. Spline path. Add points to spline. And add deviation. Yeah, look at the RBTs. Okay. Still got some going along here. But it does look like it's moved a bit off of the edge there. I also don't really like this because like obviously the deviation's so random, but it's like not going around here, you know? Not that it has to, like it's gonna be random each time, but I don't know, we gotta play around with that, I think. And that comes from this guy. So if we did like 1.5, and we said find path, add points, add deviation, right? Now we have a path going over, and that's not good. So, yeah, this one goes right over top. It's not what we want. So what if we increase our number of points, right? We say find path, add points, add deviation. Now it deviates less because there's more points, and it scales the deviation based on the distance to the last point. But it's still not good because it still goes over top of our little ridge here. So maybe do a 0.7, and then we're gonna say 1,000 for you. I don't know. We're just kind of trying some stuff at this point. Add deviation. I feel like it's not scaling the deviation anymore. Is it not? Let's see. Looking at randomize, deviate. Yeah, so we're not actually. So, So then, I don't want to do this. So maybe let me take this out, right? Say maximum deviation is our capsule radius multiplied by this scalar, which is going to be the distance between this point and the previous point. To get this, we say this minus 1. And you get distance of this vector out of, I don't know. We need some value that should be. Do we have our max distance between points set at this point? When we say deviate, I think we do, because when we say add points to spline, right? We set our max distance here. Yeah, we could do it based on that. So divide that by our max distance between points. I don't know if that'll work though, because that's going to scale them all to the same thing, right? Because they're evenly distributed. I don't know, let's try it. See how it looks. Alright, clear path. Find path, add points. Add deviation. Yeah. Not good. Yeah, that's not good at all. Plus this one, the point doesn't go outside the bounds, but the path does. And we can do something with that too. We can like adjust the tangents after the path is created. But like here too. So like, right, once this point's here, we can add something here to like, right, we can turn our tangent this way, make it smaller. That's not better, but probably adjust this one, right? Make it more of a loop. There we go. But that, I don't know how I would do that at runtime. So, get this out of here. I guess this wouldn't work either because this is making a direct distance. So instead of get location, we need get distance along. Get distance along spline at spline point? Yeah, that's the one we need. We get these, we get this one, and then this one. Right? Say, subtract the two, get the absolute value. We don't need that. That. Divide that by our max distance. See what that does. Find path, add points. We'll just do it once this time just to see what it does. What did it do here? How did it do this? How did you get ahead of you? Okay, I'm gonna say normalize. Nope. Normalize to range. Wait, that's not gonna work. No. Let's go ahead and scale this down, I think, because this is going to be too much. Let's scale this by 1.5. Do that. And then how do we get this to be between a value of 0 and 1? Well, the distance at this one is going to be farther ahead than this one, so this minus this shouldn't return a negative value. I guess we don't need that. I don't know. We'll plug this in again, see what happens. Better, but still we have points going over top the ridge. And I guess that doesn't work because you can't use the normal because the top of the ridge is flat. So if it gets right on top of the ridge, it's gonna be like, yeah, this is fine. So how do we do this? I think someone suggested that I could do something with the height map, like supply the height map and use that to determine where path points should go. That would require me to make my own like pathfinding algorithm though, and I really don't want to do that. I wonder if we... We're also going to take capsule radius, multiply it by 0.8, because we don't really want the path to be like right on the edge. I think I'm going to do that. Let's see what that does. Yeah, that keeps them more like in bounds. But we still get weird points like this because we need to scale them based on the... I guess we just need to scale them based on the Y location, right? We go back to... not this one. Right here, right? So our max deviation is our capsule radius times, well, let's do this because we're clamping them to, what is it, 0.8, right? We say multiply times 0.8, and then we scale that by the difference in Y values. So I mean, that's also assuming like we're just going off of we're only changing the X, so this may change. I don't need you. Don't need you. Do this again. This should go here. So we can go here. Okay. It's fine. Yeah, there we go. All right, so then we say split. So if it's farther along the path, it should be farther in the Y. If we take current location, subtract the Y in this location, that gets our distance in the Y. Our distance in the Y, let's say, I don't know, this distance in Y out of, I don't know, like in this case we want this one to be near 0, right? So we look at our spline, right? Select this spline point. Location on the Y is -9569. This one is -1129, so that's almost 2000, right? So we want almost 2000 to be near 0. I guess we want this to be like 20,000, right? Or we could use our max distance between points here and try that maybe? Because this max distance between points, this is max distance along the spline, not max distance in the Y. So that would technically be longer. Let's try that. Go back up here, we say clear path, find path, add points, and add deviation. No. It still does stuff like this. Maybe let's set this to a constant value of like 20,000. This, we say clear path, find path, add points, and then add deviation. See, now it doesn't add much deviation at all, which isn't necessarily a bad thing. So, you know, this path would work. Kind of goes along the ridge here, but that is still technically navigation area. Only problem with this is that it would generate, I think, this path the same every time, right? Not exactly, but pretty close. So let's scale that number down to like 15,000. Let's say find path, add points, add deviation. That changes it up a bit. But then we get stuff like this, where in this case we would just need our tangent to be not rotated. Right, we need something more like that. But we can play around with tangents too. What? Oh. Why is my... Wait. Clear path, generate endpoints, then find path, then add points, then add deviation. That's why that was messing up. Oh, just kidding. No, it's still doing it. Ugh. Okay, why do we have multiple points here? Let's do that again. So, well, we said we were gonna play around with the adding points. So, like if we hit this a couple times, then we say add deviation. stuff. Right, so it starts here, right? They're pretty evenly spaced out. Why do you go beyond? Are you not the endpoint? Oh, you are, but it adds one at the end there. That's not what we want. Hang on. I think we need to go look at our add points to spline in here. So we clear our path points. We set the max distance between points to be the number of points, which is the variable that we set. We divide our spline length by number of points. That makes sense. So then from 0 to number of points minus 1. If it's 0, then we add a point here, right? We get a point at 0, yep. And at the end, we add a point there. Otherwise, I see the problem. So it's just, it got it here, but it had space to add another path point here. So it did both at the same spot, or near the same spot. So, let me clean this up a bit, because this is kind of gross. We'll say if you're 0, right, this is our start of path. And then we'll go down here, right? This is saying end of path. And this is gross. I'm gonna put you here. Gonna put you down here. Put you up a bit. Right. And then we're gonna drag all this out, actually. Sorry, no, not all of this, but all of this. And then we can do this. Move this one out. Here. It's a little bit easier to read. Let's just do this. Start. End. And then you bitch. There we go. And then we say other. Okay, so make sure all these are world. That's correct. Let's start. Our distance is 0. That's right. At the start, at the end, our distance is the spline length. And then we set one of these. So from 0 to number of points minus 1. So if number of points is set to 20, goes 0 to 19. At 0, we go here. At 19, we go to here. For numbers 1 through 18, we go to here. So, wait, is that right? We go 0 to 19, 0 goes here, 19 goes here, and then 1 through 18, yeah, that's right. We need to add a check to see if there's a point, I guess, in between. Like, there are 2 points that are like really close to each other, and it would really only matter at the end, right? So, we could do a check here for, say, max distance between points times this integer. If this is within a certain distance of like we take this and then we take get spline length, right? This divided by this is greater than or equal to 0.95. So if this value is greater than 95% of the spline length, right, we can say if it's false, do this, right? Otherwise, do nothing. Just add a little check there. And that's ugly, I know, but let's just make sure it works first. So that way it shouldn't generate 2 points right at the end. So I guess we could quantify that further, but find path, add points, do it twice, add deviation. Yeah, so now it doesn't add one on the end here, which I think is fine. It does have 2 right here. Why does it have 2 right there? Because it should be adding deviation on the X, not the Y. But it seems like it's adding deviation on the Y too. Because now these 2 points are really close together. We could say add deviation twice, I guess. Right? Just get really wacky with it. Now we say generate RBT. It still goes around that path. Or around the ridge, rather. It's kind of on it, but we also deviated several times. Let's try that again. Find path, add points, add deviation. And generate RBTs. It still likes to be right there. Okay. So if we do this, hang on, let's give us some more space here. We're gonna do this, and then we say here, make that a little bit cleaner. Okay. So then if this is greater than, if we do a divide, we say number of points minus 1. Yeah. Then don't add it. That way when number of points changes, it'll automatically update this. Also, we want to change the slope. We want to make that a variable. It's 0.8 here. Or no, that's not the same thing. That's for the padding. So we can promote this to a variable, say boundary padding. We'll expose that one. We'll say value range from 0, 1. Okay, by default that's 0.8, that's fine. There's our padding for our thing there. Where are we putting the 0.8 in? Right here. Get our boundary padding, put it in there. Okay, so then in here, we are checking the slope, right? So we will convert this to a variable. We'll say max slope value range 0 to 1. By default, it's 0.7. That's fine. I'll expose that one. All right. Now we got a little bit more to play with. We can get rid of this deviation multiplier. We're not using that anymore, I don't think. Yeah. Get that out of there. All right. So, let's change this back to 15. That'll give us a little bit more deviation. And then boundary padding will stay at 0.8. Max slope, let's put you down to 0.6. Clear path, generate endpoints, find path, add points one more time just to smooth things out, and add deviation. That looks pretty solid to me. Pretty organic looking path. I just imagine you're walking along this path, ignore the texture. Texture is going to change. There's going to be foliage also. I know it's hard to really envision it right now, but gonna have foliage, gonna have buildings that spawn along this path, and that is going to be your level. Something like that, anyway. Let's keep playing with this because I want to make sure it works in all cases. Because I don't think it will right now. So if we go to our map adder, first let's clear our path from here. Let me just adjust this just so that it generates a new landscape. Okay, we have this one, sure. Go to our path creator, we say the box extent, generate endpoints, find path, and this one is straight across. Didn't have any issues with that. We're gonna say add points, and then we're gonna say add deviation. Generate RBTs. That looks pretty good to me. I mean, this was an easy example because it's very flat here. I do want to play around with the idea of changing up where the endpoints are, because right now they're static. But that adds a lot more complexity to it. Right now we're just trying to keep things as simple as we can. Yeah. Okay, so let's go to our first clear our path. Back to our map adder. Change it around again. So now we have a weird landscape that I think the starting point is out of bounds. Or like not navigable, I mean. But let's try it. Anyway, we're going to be changing these height maps too. We haven't really determined a set play area for these landscapes. We were just kind of playing around with a proof of concept. But let's say set box extent, generate endpoints. Endpoints are there. Find path. It was still able to find a path, so that's good. It kind of went around here because I think this ridge here is too steep. We say add points, and then add deviation, and generate RBTs. I think it put some kind of on this ridge here, which is not what we want. I guess we should up our navigable radius here. This one. Let's change this to like 3,000. Nope. Because we want it to move away from the ledge, right? Which I guess it still was navigable there. Like, if I press P here. Maybe look at this. I don't think this point here is. Like, it's not in the nav mesh. So it did that incorrectly. But I think it's because also we did this. So I think this has to be, I think max slope has to be 0.75. That's my guess, but so let's clear our path, find a new path, add points, and then add deviation. You checked right here. Here does not have any navigation, but you still went here anyway. But I guess it doesn't necessarily have to be that slope to be navigable. Is there another way we can check for navigation? Like if there's navigation data down there? Because I don't know if we really need to always do this, but I don't know. Let's just do this for now. See what happens. Find path, add points, and add deviation. So now it. Why did it do that? Oh, it moved points over there. Okay, hang on. Let's jump this down to 1200 here. We don't want it to go across areas that don't have navigation either. So, find path, add points, add deviation here. See, it had navigation there, but you still went out over it. And then you here, it's because I'm adding that random navigation. It's not just moving in the X anymore. Okay. Putting that back in. That one's better, but it's still like we're riding the edge here, you know? I don't think this is a good use case, because I don't think we're going to have a height map that's like this. So like if we were to move this down here, and then go back to our thing here, we say set box extent. We've now moved it, right? Now we say find path. Oh, nope, sorry. Generate endpoints, then find path. Oh, it doesn't work here either. I don't think this nav mesh or this area will work. So we just move it back over here. Okay, find path. Yeah, okay. You're good there. Let's try a different map. That one's too easy. That's the one we were just at. Okay, here's a new one. This is a mostly snowy area. A ridge kind of going through the middle of it. So let's look at our path creator. We say set box extent. We say generate endpoints. We say find path. It made a straight line. It's right through the middle. And then add deviation. That looks pretty good. Generate RBTs. Yeah, that's a pretty good one. So just imagine this. If I press play here. Ooh, our height cog needs to be increased a little bit. Nope. So you'd spawn where this path was. Right here. You'd spawn somewhere around here. You have to go. Well, you don't have to go along this edge, but or along this path, but this is where like the village will be. They'll be building spawning along this path here. Use it as a general guide. It'll be foggier than this, I think. We want to make sure we're going towards the end. We'll have to make our area a bit bigger. And this will be the end. And this will be the way to the next village. Yeah, that's cool. This again. Alright, this one pretty straightforward. Set box extend, generate endpoints, find path, add points, add deviation, generate RP. Right. So it kind of squiggles, but I think it's okay. You know, it doesn't always squiggle either. We have this big long straight section. Only problem is we find path, add points, add deviation, generate RVTs. I guess that's a different path. Yeah. It's still kind of the same, but yeah, so it doesn't give the same path every time. And this one's easy enough because it's pretty flat. But I think I'm happy with this for now. I think we can work with this. We can always come back and adjust it as needed, of course. But I think this is what we're gonna go with. For now, anyway. So, I don't really want to mark this off just yet, but I think we're good. You know, obviously it can be tweaked in the future, but I think for now, this is what we're gonna go with. So, let's do this. There we go. Alright, next thing is refactor file structure. We've been needing to do this for a while. Hang on. We're just going to save all of this first. Alright, let's go in here. So, we need to move some stuff around. Our game mode and our Viking game mode can go into blueprints. Our path plane. Oh, okay. This can go into BCG. These two things can go into UI. These two, the volumetric clouds, it's a material and a material instance, so I guess it can go into materials here. Okay. And then if we go to audio, that's fine. Blueprints here, let's see. Map adder. World generator. Okay, so we're gonna go to maps, raid. We're gonna move you to world generator. Path creator, map adder, yep. Instance ramp spline. I'm not sure what that is. I think that was Tyler's thing for the home village. Move you inside of maps. Okay, that's fine. And then if we do do this and say fix up redirectors. Give it just a second for that. Not resaved, I mean not. Okay. Save all. Alright. Inventory basically can go into blueprints. So we're gonna put you into blueprints. I'm gonna move a lot of stuff, I know. Input can stay there, that's its own thing. Low-poly Viking World, that's its own thing. Main menu doesn't have anything in it anymore. Maps, I don't think we need to do anything with this. Oop, we gotta move you to blueprints. Main menu is there, raid is there. Materials, fine. Models, I think we're good there. Movies, we don't have anything there. NPCs can be renamed because this is going to be new folder, basic, or I guess enemies, because we're gonna create a parent enemy later. But if we do this, put all you inside of here. Right, content. PCGs, our PCG volumes, our physics material for PCG, which I don't think we're using anymore, but we also have our path plane. Our player is all this. That we're gonna take this, all of these guys, move them into a new folder inside of blueprints. Okay, and then this one's going to go into models. And then splash, that's just for a thing there. UI content can stay there. UI, I think that can stay as its own. Weapons can be put into blueprints. Actually, I'm gonna hold off on weapons because I should probably hold off on the player too. I gotta work with Tyler on this because I am he's working on this stuff and I don't want to overwrite his stuff, so I think I'll save that for later. So we're gonna go ahead and save all. And I think that'll be it. think I'm gonna call it there. So, on Tuesday, what am I gonna do on Tuesday? I don't know. I don't know what we're gonna do. I'll have to figure that out. But yeah, we're gonna call it here. I will be streaming again on Tuesday at 7 if you wanna come hang out then. But on that, I'm happy with the progress we're making, and hopefully we'll keep that going. So have a good rest of your Sunday night, and we'll see you on Tuesday.